This is the Math 2 lesson summary video for the lesson entitled Cut by a Transversal. In Lesson 4 of Unit 7, Cut by a Transversal, the purpose of this lesson is to be able to write proportions comparing the sides in two similar triangles when a parallel line is drawn to the third side of a triangle. This is sometimes called the side splitter theorem. For example, if you look at the diagram, you can see that there is a triangle, a smaller triangle, triangle ADE, within a larger triangle, triangle ABC. BC is drawn so that it is parallel to DE. In this lesson, we will take a look at why these two triangles are similar, and then what proportions we can write to help us find missing side lengths. In Lesson 4 of Unit 7, Cut by a Transversal, we are asked to draw two intersecting transversals on a sheet of lined paper as in the following diagram. We are asked to label the point of intersection of the transversals A, just like in the diagram, and select any two of the horizontal lines to form the third side of two different triangles. So I'm going to use this diagram here, and I'm going to take a look at number 1. So with lined paper, we do know that all of the lines will be parallel. So therefore, I've marked in red here that BC should be parallel to line segment DE. In 1, it says what convinces us that the two triangles formed by the transversals and the horizontal lines are similar. We'll recall our two properties of similarity. We do know that triangles can be similar if we only know two angles, which was our angle-angle similarity theorem. If I look at the smaller triangle, triangle ABC, and then the larger triangle, triangle ADE, I do notice that both of those triangles share angle A, which means that those two angles are congruent. So what I've done down here is I have redrawn those two triangles, the smaller triangle, triangle ABC, and the larger triangle, triangle ADE, and I've marked those angles, angle A, congruent. If we can find one more angle that's congruent in those two triangles, we do know then that they are similar. So let's take a look at the original diagram that we drew. If BC is parallel to line segment DE, then we know that corresponding angles must be congruent. We've learned that before. So angle ABC will be congruent to angle ADE. And that is enough. I'm going to mark them in this other diagram. Because we now have two angles that are congruent, we can say that these two triangles are similar by AA similarity theorem. So we did say angle A was congruent to itself, and angle ABC was congruent to angle ADE. So that's enough, and we know that these two are similar. So then we're asked in 2, well, I've already labeled the vertices of the triangles and I redrew them. We're asked to draw or write some proportionality statements then. So recall that if two triangles are similar, which we've just proven, then their sides will have the same ratios. So let's write some proportionality statements. So if I look at my two triangles, I'm going to choose corresponding sides. Let me just highlight corresponding sides with the same colors. AB corresponds to AD. BC corresponds to DE. And AC corresponds to AE. And I apologize about that. Looks like it moved my green one. Okay. So let's write some proportionality statements using light colors. So AB should correspond to AD, and we could say that that should be equal to AC divided by AE. So what we're doing is we're writing a proportion like we've done previously to relate corresponding sides. We could also say BC over BA or divided by BA is equal to DE divided by DA. So we can write many proportionality statements. We got very good at that at the beginning of this unit. In number 3, we're then asked to select a third horizontal line segment. So I'm going to say that this one down here will be the third horizontal line segment. And let's label that FG. Okay? So now we have 3 triangles. And I'm going to take that large triangle and I'm going to draw it on my paper. So that large triangle will be the large triangle AFG. And if you notice in the original diagram, angle AFG should be, and I apologize, there should be 2 tick marks on those. Angle AFG should be congruent to the other 2 angles because they are all corresponding. So therefore I know that this large triangle here will be similar to the smallest triangle and the medium triangle. Okay, so then we're asked to write some additional proportionality statements and verify them. So in class we did measure, but we are going to take a look at some additional proportionality statements. Okay, I'm going to highlight here as I go through. So AB is this side in yellow. AB plus, I'm going to do it in a different color, but AB plus BD. So that whole length, AD, but I'm going to write it as AB plus BD. So I'm taking 2 parts, the one in yellow plus the one in green, and I'm going to write it in the numerator. So let's say AB plus BD over AB, so then I'm just doing over the little yellow piece, should equal, let's look at the other side and see what corresponds, AC plus CE divided by AC. So there's a proportion that would relate another way to write a proportion, but using pieces of 2 sides. So the next part of this lesson, we actually measured the lengths of the sides in our triangles using a ruler. But for right now, I'm just going to write some lengths on my paper. The length that I've written for AB is 5 units long, for BD is 2 units long, for AC 10 units long, and for CE 4 units long. So what we're going to do here is we are going to write a proportion relating the sides, just like we did in the previous example. So in the previous example, AB plus BD, so in this case, AB is 5. Let's write it out first. AB plus BD divided by AB should equal AC plus CE divided by AC. So let's plug in the numbers that we have. The length of AB is 5, the length of AD is 2, and AB is 5. And that should equal AC, which is 10 plus CE is 4 divided by 10. So let's simplify that. The numerator, I get 7/5 equals 14/10. If I simplify 14/10 and divide numerator and denominator by 2, I do get 7/5. So what does this tell me? This tells me, first of all, I knew that these triangles were similar because they both shared angle A, and they both had a congruent angle that was corresponding. So therefore, because I knew the triangles were similar, I knew their sides had to be proportional. So I can write a side length, or I can solve using a proportion. So let's say that this was now a variable instead of it being 5, and we wanted to find it. So we would do the same thing that we just did, except we would plug in an x in our proportion. So we would have x plus 2 divided by x equals 10 plus 4, which was 14, divided by 10. Now, think about how we would solve this. We would have to cross multiply, which is one method to do this. So in this case, we would get 10 times the quantity x plus 2 equals 14x. And we would keep going to solve for x. So we could distribute the 10. 10x plus 20 equals 14x. Combine our x's, so minus 10. So 20 equals 14 minus 10 is 4. Divide by 4. And 20 divided by 4 is 5. So knowing that these are similar is super important because we will be asked to find missing side lengths. In triangles, when a triangle is put within a triangle, this is sometimes called the side splitter theorem. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.